Hi, this is Tom Cherryholmes with another video in the Retrocomputing Archaeology series. This series of videos is intended to serve as a comprehensive reference to a variety of retrocomputing subjects. In this video, we'll talk about a deep dive on the Coleco Adam. The Coleco Adam was the ColecoVision family computer system, which was developed by Coleco and was sold from 1984 until early 1985. And honestly, the reason this video is being made is because we're actually trying to take and show how this system is used in context, real usage, so that you can see what using the system was all about. But first, we need to do an overview. And to do that, I'm actually going to use my desktop machine here with my presentation notes on the left-hand side and a browser window on the right-hand side as I take and move through various things in the overview here. But we'll also be switching between various camera angles here so that we can show different things. Starting off with essentially the audience of this video. Who is meant to be using this video? Well, this video is for people who have heard of Adam, for people who haven't heard of Adam, but regardless of which, people who want a comprehensive overview of the entire system with all of its various features being used in context, so you can have a concrete idea of what using the system was like. It's meant not only for interested enthusiasts, but also for YouTube content creators to get good, solid information on how the system was being used. Or to start off with, I'm going to take and show two commercials that were displayed in North America during 1983 and 1984 to show off the features of Adam. First being, Is That Legal?, which shows off the standalone Adam.
You'll never finish by morning.
No problem.
Now, command the powers of Adam with professional keyboard, high-speed memory drive, and built-in word processor program, all in one package.
Oops, you gotta start over.
Relax. Adam, read that paragraph.
Is that legal?
And print.
Adam, even a letter-quality daisy wheel printer.
You did it!
Adam, my launch sequence.
Is that legal?
Command the powers of Adam and program your future.
And the other commercial showing the expansion module number 3.
While Atari keeps trying to sell you new systems, like the 5200, with ColecoVision you only need one system, because ColecoVision expands to give you a Super Action controller set with Super Action Baseball, a driving module with turbo, and only ColecoVision plugs into the Adam module to become the complete Adam computer system. Plus, you get $150 in vacation savings certificates. $150, good for any vacation package, if you buy ColecoVision now. Sorry, Atari.
So really, why the Coleco Adam in the first place? The answer was pretty simple. They wanted to make a computer that they could market to little Billy, little Alice, so that they could take and do their homework and then print out their homework, get it ready for class. And when they finished with all of that, they could turn right around and go play Buck Rogers or Zaxxon. And to do this, they needed to make a machine that basically had everything that you needed for a complete computer system in one box to be bought all at the same time. To do that, they were targeting essentially a $600 price point. And we could see all sorts of advertising materials showing that this was what they were intending to do. Note the date on this particular issue of Popular Science here. This is September 1983. And it is shortly before they actually started doing the initial test pilot runs on the East Coast. But they also wanted to do a $400 version if you had an existing ColecoVision, which they called the expansion module number 3. It was called number 3 because there were already 2 other expansion modules for the ColecoVision. Number 1 being the 2600 adapter, or the game changer. Wait, was that the Intellivision? Anyway, and EM2 being the steering wheel. And all of this basically including everything you needed in the box, including the printer, which basically takes up half of the very large box that this is sitting in. And you may have noticed, if we look back at this again, you'll see that we see something that looks like a tape drive. This does not look like a disk drive. High-speed tape storage, you see it right there. And you may be wondering, why tape? Well, that's because disk drives were extremely expensive. And I can really bring this point home by opening an issue of Creative Computing from January of 1983. And if we look at the prices, we'll see some interesting things here. In particular, you'll see that a single-sided, single-density disk drive for the TRS-80 Model 1 was $300 US. Just the disk drive. This does not include the disk controller that you need for the disk drive to work. And a similar situation with a disk drive for the Zenith Z89. $379. You'll also see a whole bunch of disk drives that say call here. These are third-party disk drives for the Apple II systems. And these all had more capacity than what Apple was offering with their Disk 2 and Duo file disk drives at the time. These were at least $500, if not more. You'll also see right here 3 Corvus hard drive systems. These are just the hard drives, 5 megabytes, 10 megabytes, and 20 megabytes respectively, ranging from $3,000 to $5,000 in price. And you still have to pay $500 or so for the disk controller. So really, to put that in perspective. Okay, no, so why do this video? Well, at most, there were 500,000 of these Coleco Adams that were made between 1983 and 1984, when Coleco finally pulled the plug. And the big reason for that was they didn't sell as well as Coleco had hoped. And the reason for that ultimately has been pinned down to production problems in the pilot units that were shipped to the East Coast. Word got around very quickly. And yes, these production problems were real. But I must point out that Coleco solved these production problems very quickly, in a matter of a couple of months. But the stories still persisted. And because of these early production problems and the stories that went around, because of these bad units, there is a whole lot of apocryphal bullshit that has been floating around about these systems that I am directly trying to address with the production of this video reference. Really, what is a Coleco Adam? Well, a Coleco Adam in and of itself is a full-blown computer with its own data storage that you do not have to buy separately, and a printer that you do not have to buy separately, and a ColecoVision, which you either already have or do not have to buy separately, stuffed in a box that makes train sets look small. And I am so not kidding here. There are so many pictures that you can find on Google, on the web here, showing the ridiculous size of these boxes. It is absolutely amazing. And they had to be this big because it not only contained the system, but a full-blown printer. and all the accessories. I mean, we can just basically look at that. Yes, absolutely huge. And they came in two varieties. You had the standalone system here, which is the blue box, which basically contains the Adam memory console with the ColecoVision embedded inside of it. And you had an expansion module number 3, which came in the red box with all the same accessories. The main difference is that you needed an existing ColecoVision, which you can see right here on the back, to take and plug into. But it still had the printer, still had the keyboard, still had the storage units, memory console, everything that you need right there. And you'll notice the prices right here. By the time the Coleco Adam was in production, they had to raise the prices that they had announced just a few months before slightly. And so the system wound up being shipped at a retail cost of $700 for the standalone unit and $500 for the expansion module number 3. Now to do this next part, I'm actually going to take and flip over to my overhead view so we can actually kind of show what this system, so that I can take and show you various aspects of this particular system. But before I do that, I'll go ahead and just kind of rattle off some of the overview. This is a machine with 64 kilobytes of RAM, but it also has 16 kilobytes of DRAM for the video display processor. This is for a TMS 9918A video display processor. Or at the 9928 if you're using a ColecoVision, but functionally the same chip. It uses a Z80 CPU running at 3.58 megahertz. It also has a 76489 DCSG sound generator, the same one that's used in the TI-99/4A. Now, rather interesting here is that in addition to the Z80 CPU that we have here, we have two 6801 microcontroller units also present in the system, acting as input and output processors for the AdamNet, which provides the peripheral bus, and to control the logic side of the digital data pack drive units. There's also a 6801 sitting in the printer as well, which I don't have listed here. But technically, yes, this makes it with the Master 6801 and the Z80, and with the Master 6801 able to do direct memory access into the Z80's memory space. That makes this a multi-processor system. So I'm going to go ahead now and flip over to the overhead view. We'll get a good look at the unit right here. We have right here a Coleco Adam here with its memory console. And we have right next to it on the left here, we have our SmartWriter daisy wheel printer. This machine is extremely approachable. You'll see right here on the top, starting over here on the right-hand side, we have a cartridge slot, which can take any standard ColecoVision cartridge. Easy enough to use. Boom, right there. We have two reset switches on either side of the cartridge slot, which shows the dual nature of this particular machine. The one on the right-hand side is to take and enable the ColecoVision side. The one on the left enables the Coleco Adam side of the system. We also have right here a door, which when opened exposes the expansion slots underneath. We have 3 expansion slots, each with different capabilities intended for different particular expansions. For example, the first slot right here was intended for the modem. The second slot was actually intended for ROM expansions, such as language cards for marketing the Coleco Adam in different markets. For example, there were ROM cards for French and there were ROM cards for German. and which basically put SmartWriter and the various system and SmartWriter in those languages. We'll talk about SmartWriter later. The third slot right here is intended for RAM expansions. And in this case right here, I have a 1 megabyte RAM expansion sitting right here, and I'm using the second card slot right next to it as the addresser, so to provide the missing address lines so that the RAM card can actually function. You'll also see a single tape drive in here, and I have a blank spot for a second tape drive. Adding a second tape drive on this machine is very easy. All you really have to do is unscrew these 3 screws, pull out the dummy plate, slide in your other data pack drive, and connect leads coming off of that data pack drive into the connector slots over here on the right. That, seeing the inside here. On the front, you will see basically the 2 data pack drive windows right here. And you will also see a connector that is labeled keyboard, but this is actually also an AdamNet connector you can use to also take and daisy chain peripherals in before you connect the keyboard. On the left-hand side, we have a power connector for the printer. The printer is actually providing, ironically, the power for the rest of the system and a power supply board that's in the back of this printer. This connector also provides the AdamNet signals so that the printer can communicate with the Adam, and vice versa. There is also an AdamNet connector that's labeled as AdamNet right here that you can use to take and attach peripherals such as disk drives. Meanwhile, on the right-hand side of the system, we see 2 joystick ports, which can take 1 or 2 ColecoVision joysticks. The standalone Adam comes with 1 joystick. You can buy an additional one for extra. Any standard ColecoVision joystick can go in here. You'll also find a door which houses the ColecoVision expansion card edge right here, which is used for various expansions. And any standard ColecoVision expansion that would go in the expansion slot on the front can also go in this slot. 2 examples of this are the expansion module number 1, which provides the ability to play Atari 2600 games, but also Adam-specific expansions such as the Adam Auto Dialer or speech synthesizer module, etc. Looking on the back of the unit, we find all of the video connectors for the system, starting with what is basically a 6-pin DIN connector, which is roughly equivalent to the same connector that's used on Commodore, Atari, TI systems. Like you could use a 5-pin DIN connector first. You'll also find a composite video signal out here beyond RCA jack. You'll also find another RCA jack for the RF modulated TV output with its corresponding channel change selector right next to it. That's the memory console in and of itself. Looking over here to the left-hand side, we see the SmartWriter Printer. And the SmartWriter Printer is quite literally a daisy wheel printer. It takes standard Xerox Diablo high-type cartridges, which ironically you can still find. It's kind of funny. And it can take any standard Xerox Diablo high-type daisy wheel. And Coleco basically sold a handful of different ones available for this system, including but not limited to Pica 10, Courier 72, Prestige, etc. So it's easy enough really to maintain. There's really not much to it. You have little clasps right here on the sides of the printer. When you pull them in, you can get access to the printer mechanism so that you can remove the daisy wheel. And there's a lever right here so that you can remove the ink cartridge. Easy enough to deal with. Very straightforward. The entirety of the printer logic board is literally stuffed right here in this tiny little board that's at the bottom of the printer right here, with the majority of the processor and logic circuits underneath this metal can right here. Simple enough. This particular, there were two major revisions of the printer that were made. This is one of the older units, just the mechanics that were updated over time. So, but they are functionally the same. This is an 80-column carriage, and it prints at an average speed of roughly 10 characters per second. Not the fastest thing in the world, but the printer output for the time was quite excellent, being comparable to typewriters, which was really its intent, especially compared to dot matrix printers at the time. It's easy enough to put this cover back on. You just need to take and bend the bezel ever so slightly, and the cover will go right back on without any issue. So moving forward, we'll also finally, before we get to the demos, we'll do one last little talk here about the keyboard. The keyboard here is a nice compact affair. Has 76 keys, which is a mixture of your alphanumerics, but it also has a number of black programmable soft keys, 6 of them, which vary from application to application and are numbered with Roman numerals. These are the smart keys. You also have a number of command keys, which were primarily put there for the purpose of the word processor, but other applications can use them for various purposes, such as move, copy, store, get, clear, insert, print, delete, etc., as well as an arrow cluster on the right-hand side with home key in the middle, a nice full-size Selectric style return, and in point of fact, the layout for this particular keyboard is somewhat similar to the IBM Selectric, with the quote keys being right next to the return key and @ symbol right underneath the 2 here. There are other specialized keys as well. You'll notice that there's an undo key right next to the backspace on the right-hand side. And you'll see that there is also a wildcard key that's used for specifying a special wildcard character. It usually looks like a set of ellipses to take and select a range of bits of information in an input. You also have a key here for escaping to the word processor. We'll see this actually in use when we take and flip over, show a demonstration of the system. Coincidentally, all of the keys legends here are all done in the handle Gothic typeset, which I thought was an interesting touch. Somewhat futuristic, I guess. And of course, power illumination right here when the system. So with that, let's go ahead. I'm going to take the keyboard off here. We're going to put this system into demonstration mode. Give me just a moment here. Flip over to the next part of our demo. So for the next part of this demo here, for the demos that we're going to have I'm primarily going to be using a full screen display with our Adam. I'm going to cut in at various times to our overhead camera views as well. And I have a handheld camera view that I will use for certain things, such as showing how the tape drives work. With that, let's go ahead and switch to our overhead camera view. And we need to answer the question of how do we turn the system on? Because if you look at this system, it's not immediately evident how to turn this on. There is no power switch in front of the unit. There is no power switch on the keyboard, but the power switch itself is actually on the printer. If we look at the back of the printer, I'll move my hand back to the very back. In the middle of the printer, there is a power switch. Turned on, engages the printer, and turns the system. And the system is on. We can flip over, look at our Adam here. This is literally what you see when you first turn on the Coleco Adam. Unlike other systems where they boot into BASIC, this system boots into a word processor, which it calls SmartWriter, but with an added twist. You'll see that it currently says not SmartWriter, but Adam's electronic typewriter. And it literally functions exactly like a typewriter. If we take and turn on my overhead view here, we can literally see as I start typing, you can see right there, it functions exactly like a typewriter. In fact, if I take and bring up my handheld view here, we can see what it typed right over here. There we go, right there. You can see the output that we did right there, and just by typing it in. Go. Out of the way here. This is literally how it works when we first turn on the system. However, if I take and press the Escape WP key, we will see that we've now flipped into word processor mode, and any text that we've typed in the typewriter mode will immediately get migrated over to be used by the word processor. And this particular word processor is very basic and very straightforward. There's really not that much. They basically did the bare essentials of what most people would need for word processing. You have options for setting your paper types, for setting your tabs, and in Smart Key number 1, pressing Escape will exit that. In screen 2, you have a basic way of setting how the screen is actually rendered, with the major function actually being whether you're in roller mode, which we're in right now, where everything fits on one screen, or we're in moving window, where the screen will scroll as you type across to match what will actually be printed on the page. You also have in screen options the ability to take and do things like setting your color preferences. Maybe you want white, maybe you want green, black, gray, blue, whatever, done, etc. But you also have the ability to do things like searching for text. So easy enough, bam, typing in, finding things, okay, boom, bringing us right there, automatic, with the option of being able to take and do replacements right then and there. They felt it was very important to try and figure out what most people were going to be using this for, and to minimize the amount of context switches that needed to happen as you move through the system. This is why certain functions are only available as you take and dig down through and start using aspects of the system. We'll go ahead and press Smart Key 6 for done. You also have highlighting functionality, so you can select different parts of text so that you can do certain things like cutting and pasting or erasing it, moving things around, that sort of thing. But you also have the ability to do things like making super and subscript text. So, I mean, as an example, if you needed to take and write the equation of E equals MC squared, well, you can. So all you really have to do to make that work is E equals MC superscript, and turn off the superscript here. And if we were to actually take and print that, how do we print? Pretty simple. There's a key over here. If we look on our overhead, we'll see our print key right here. All we have to do is press it, and we get the ability to take and print our workspace. Pressing the 5 key, we're in single sheet mode, automatic page numbering, sure. Let's go ahead and print. And we can see now that we've done this, if I actually take and go down just a little bit, we will find if I flip over to my handheld, moment, we can see right here the superscript bit that we wrote along with the text that was already kind of in the buffer. But there we go. So nice, huh? Let's go ahead and get the overhead camera out of the way here for a second. And I'm going to take and press the clear key on the keyboard here to clear the workspace, and press 6 to clear all of the workspace. Yes, I'm absolutely sure. So I press the Smart Key 6 again. Everything is nice and clear. Otherwise, for the next step, if I were to do that, it would take and load in addition to what was already in the workspace. And to do this, all we really need to do is press the Get key here and to press 6 to get. Now, in this case right here, there is nothing actually inserted into the drive. So what I need to do is I need to go grab my documents tape. I'm going to take and move the keyboard out of the way. And I'm going to go grab my documents tape. This is a digital data pack. It's the primary form of storage on the Coleco Adam. And in fact, if you look close enough at it, it looks oddly enough like a cassette tape, but there are some differences. Holes are in different places. For example, there are 2 additional stabilizer holes on the back here to ensure that you don't put this in the wrong way, but also to increase the amount of stability. The other thing, because this particular tape transport is always engaged and is not using a pinch roller and cap stand, the holes that align the tape path are also in different positions on this tape as well. We'll go ahead and insert that into my unit here, but I will take and use my handheld to do that so we can see it. See here, we have all sorts of interesting glitches here. Here we go. Tape display here. We push the little ejection lever, pull this out, and all we have to do at this point is insert the tape with the label facing out into the tape caddy and close the door. I'll take and turn on some light here so you can actually see the tape transport. And I'm going to press, now that drive A is lit up, I'm going to hit drive A here which lights up the tape transport. And you can see this tape is moving very fast. Believe it or not, this tape is moving at 20 inches per second while reading and 60 inches per second while seeking. So we have an announcement. Let's go ahead. We have a listing of files that are in our directory here. Let's go ahead. I'll turn off the handheld real quick. Pull it away. And I will take and select a particular file. File names inside of the EOS operating system on Adam have 12 possible characters plus or 11 characters plus a file type, byte, which indicates what type of file it is. So in this case, we have a file. I'm going to take and pull up an announcement here. We're going to take and press the 6 soft key to get that file and to pull it into memory. And while that happens, I'll bring up the handheld again, and we'll have a little look. There we go. It's pulled that file into place. Here we go. Now we can modify it. Bring this out of the way. And, well, let's say, for example, we actually need to change the announcement here. This is the formation of a new club. And when this announcement was made, and turns out we needed to wait a little bit on this announcement, and it's not in March, but it's in April. We can do that pretty easily enough. We can just edit it here if we want to. We can also use search and replace. Then we can turn right back around, margin, tab, etc. Okay, great, looks good, looks okay, bam. And if we wanted to, we could go ahead and we could print it. Sure, why not? Press the print key, print workspace. Go ahead and print it. There we go. So now that we've done that, we might want to save it. So all we really have to do to make that happen is to go ahead and press store and get, just like we did to save the file. And we'll go ahead and store the workspace, pressing the 5 key, storing it on drive A. And we'll go ahead and store it again. Since this file has already been named, you can see it on the lower left-hand corner. We don't have to type. If we wanted to type this in as another name to make a new file, we could, but we don't need to. So just press 6 to store. And there we go again. And now it's writing the file to the tape. But it is actually also storing a backup of the file on the tape as well with the same name with a slightly different file type. And I'll show how we get to that in just a moment. But yes, you can already immediately see one of the downsides to using tape storage like here. While it is considerably faster than audio cassette, it's still slower than using a disk drive. But it worked. And you can see it's actually doing its job here. Again, this tape drive is actually functioning. It's seeking for information at 60 inches per second, and it is reading and writing at 20 inches per second. But there we go. So now this is done. We can see that that's there. Now, if for some reason we needed to actually pull up the backup of this particular file, we could hit clear. We could clear the workspace, because if we don't, it will take and load it over the top. It will load it and right after the copy that we currently have in memory again. Press Store Get, press Get, go to Drive A, and you'll see that there is a function key, a smart key for backup file directory. And if we press it, we'll see that our announce backup file is here. And if we go ahead and press Get File, it will pull that file out for us with the older version of the announcement. So you'll see the older announcement, now March 1985 instead of April. So there you go. There's your backup file function. Now the interesting thing as well is that all of this works very well with the disk drive. And for that, I'm actually going to go ahead and we're going to clear this out. We're just going to take and clear the workspace. Sure, let's just get rid of all this, get this out of the way. And I'm going to switch over to my overhead view entirely. And we are going to go grab, real quick, a magical spot underneath the desk, Coleco disk drive. This works with the disk drive too. Disk drive can use SmartWriter just fine. You have right here a Coleco disk drive. This was one of the very last peripherals made for the Coleco Adam. They store 160 kilobytes worth of data on this particular format of the floppy, and it connects up to the Adam using the AdamNet connectors, which are here on the back of the drive. Barely see them here, the light's hitting them just fine. It's very easy to plug up, and there's a connector for power. There's also a switch to take and specify whether or not this is drive 1 or drive 2. So we'll go ahead. I'll put this right next to Adam on the right-hand side here. Plug this guy up. What we really have to do here, take the AdamNet connector, all you have to do, there are two AdamNet connectors, one for input and one for output. The cable coming in goes into input, anything else that needs to be changed goes into output. Again, all we have to do, we just take and provide power. Power. Turn on the floppy drive, and there's an illuminated power on the floppy drive. We take and pull up my handheld. We can see it right here. Here we go. Ready to go. So With this in place, take and reset the Adam. It will see our new disk drive here. It can use it. Now, since there was a tape in the drive, it is actually taking and trying to read from it. There's no boot sector, so it will go straight back into SmartWriter. And we'll continue this over here in our Adam display. We come back to our typewriter now that I've hit the reset. And in fact, this is literally what happens no matter what you're doing. If you take and press the, if you actually take and press the reset switch, it will take and reset the Adam and do its whole boot up process. So now we have a disk drive set up, it's ready to go. And I will take, as part of this process here, we have a formatted floppy disk I have right here. I will take and put it into the drive. The ColecoVision disk drive has a sensor that will automatically detect whether there is a disk in the drive or not and report it back to the system. We close the drive, and now if I take and press the escape key, go into the word processor, press store get, we'll take and grab a document off of the data pack here. And you'll see now that there are entries for drive A, which is our first data pack drive. Drive B would be our second data pack drive. And our first floppy drive here is being represented as drive C. We'll take and press the 5 smart key here. I don't think there's anything on this here, so okay, there's not, no big deal. We'll press 4 to select drive again. Press 3 to go to drive A. We'll seek for and grab our announce document, and I will put it onto the floppy here. Take this, get the file, bring it into memory. You'll see that came in rather quickly, and there's our announce, ready to go. Okay, there it is, great. Now we take and press the store get key again, store the workspace, and we'll put it on drive C. And the file is called announce. It already knows the file is called announce, so I don't have to put in the name again, but we'll go ahead and put it right here, ready to go. And I will turn on my handheld camera here so that we can store the file. That's it. It's integrated into the system and it just works. I mean, there's nothing else that we have to do. And if I take and go store get now, get, go to drive C, we see our word processing document right there. So notice, I didn't have to do anything special to set this drive up. All I literally did was plug it directly into the AdamNet here, give it some power, reset the Adam, and SmartWriter already knew exactly how to use it. And that's one of the nice things about the integration of AdamNet into the system, very much so. So a little note. We'll go ahead and hit escape here. And I want to make a little note here. Some of you may be asking, how many pages of text can SmartWriter actually store in memory at once and work with in memory at once? This answer depends on whether or not you have expanded memory. If you do not have any expanded memory in the system, that is, you only have the 64 kilobytes of space, and you don't have any RAM expansion, you can work with 16 pages of single-spaced text inside SmartWriter. If you have the 64K RAM expansion on your Adam, you can work with 32 pages of single-spaced text. It does that quite well. So there we go. Moving on to our next set of demos, I will now demonstrate the SmartBASIC programming language. SmartBASIC is an AppleSoft compatible version of BASIC, meaning that it not only has Microsoft BASIC compatibility, but it also implements such things as Apple II compatible graphics with some small change. To use it, all we really have to do is take our SmartBASIC data pack, looks the same as any other, and put it into our data pack drive and press the computer reset, which will cause it to boot. This takes up approximately 28 kilobytes of space, so it takes a few moments for this to load. You'll see that it's actually rewinding to the middle of the tape here because it's going to read the catalog to look for any program that it wants to take and start up automatically. In this case, there isn't one, so it will simply drop us to the SmartBASIC prompt. You'll be able to see in the show notes here, the bits and pieces of code that I'm about to show here, but these demonstrate the AppleSoft compatibility for showing different graphics functions. And we'll start with low-res graphics. To do this, we'll take and use the catalog command here to look at the files that are currently on this particular data pack, and we see a handful of demonstration programs that I've put together here. We'll go ahead and load boxes, doing it exactly the same way that you would in AppleSoft BASIC. You'll notice that by default, unlike on the Apple II, uppercase is not required. It will take and change case for you automatically. And you can see right here, it loaded that particular file pretty quickly. We'll go ahead and list what we have here, and you'll see a series of commands that will draw random boxes on the screen using Apple low-res commands, such as gr to initialize graphics, print to print some text at the text window at the bottom of the screen, and H-line and V-line to take and draw horizontal and vertical lines. Pretty simple and pretty straightforward. This is what it looks like. As you can see, a pretty darn good approximation of Apple II low-res graphics. It works pretty well on that. We can go ahead and, just like on an Apple II, we can hit Control-C to break out of the program. We can type text. to get back into text mode. And we can, of course, look at some of the other bits and pieces that are on the disk here, on the data pack. Now, it is worth noting, before I continue on, I have the disk that we have from earlier still in the drive. And if I take and do a catalog on D5, for example, because apparently there was support for up to 4 data pack drives, it would have been interesting to see how they were going to pull that one off. If I do catalog D5, we see our announce file that we wrote in SmartWriter here on this catalog. I can just as easily, now that I've set D5 as the default drive, I can do boxes D5, or I can omit that entirely, and it will save this basic file onto that disk automatically. So again, the disk drive also works here in SmartBASIC just as well. Moving on, we'll go ahead and go new, and we'll do catalog. Right now, it's sitting on my, because I've set the default drive to my disk drive, I need to do catalog D1 to get back to my digital data pack drive. I'm going to load my next program, ArmSigns, which displays a series of, looks like there we go. I bumped another key. Anyway, this particular demonstration plots a series of sine waves using the high-res graphics mode, which approximates Apple II high-res, using the bitmap graphics mode available on the TMS 9918. This carries with it a handful of differences. One of which is that you actually have more colors available to you in this mode on this system than you do on the Apple II. Whereas on the Apple II, you would basically have the black, the white, the green, the purple, the bright blue, and the orange. On this system, you have the complete 15 color set that is available, the video display processor, bitmap mode. But unlike on the Apple II, you only have 256 pixels across on which you can draw instead of 208. But those are 256 pixels that you can draw across. And you don't have to worry so much about the typical color clash issues that you see on Apple II. But as you will see in the next demonstration after this one, there is a color clash issue all its own. This is an example of something you might need to do for school, a simple little program to take and plot some sine waves, all using sine wave harmonics, all using different colors. And as you can see, it's doing that just fine. It's just doing a real bang-up job, and it's very easy to use, and you can take existing Applesoft Basic programs and reasonably carry them forward to work here in SmartBASIC with minor modifications. Very simple, very straightforward. Now, if we go ahead and look at the catalog again, there's another program that I have here that does a Moire pattern that I'm using here to take and demonstrate a color clash issue that does occur on 9918 based systems. The bitmap mode on 9918 based systems allows you to assign color to a specific foreground and background color combination to an 8x1 area of the screen. That means 8 pixels across and one line worth of attributes. So because of that, you get some interesting color clash that happens, which you can see here. We'll go ahead and load this. And you can see even here, we're actually doing a pretty good job here of just taking these programs, loading them into memory, and it's loading them off tape, and it's not taking that long. We have Moire patterns, and it's just drawing lines very closely together to take and with the jaggies of making Moire patterns. And they're doing it, and it's cycling the colors through. And we'll see here that we start with a green color pattern here. So far, so good. But you'll see as we use the other colors and we start changing color attributes, the 8x1 color space for color attributes becomes extremely apparent. And this is just an artifact of using the graphics 2 mode on the 9918, and not a limitation of SmartBASIC itself, but rather the video display processor chip. Control C to exit. And as a final thing here, we'll actually take and load a simple little program here that we might have written as kids to take and password protect our data packs. There we go. Just a simple little program, draws a little picture here, gives us ourselves a little password prompt with a secret password. Nope, wrong password. But if we type in the right one, there we go. And of course, we could just as easily take and save that as hello for this tape. So the next time when we take and put in this tape, it will take and go up to that. But it has to be. So you know. So that's the end of SmartBASIC right here. We'll move on. Moving on, we take and go to our next programming language, SmartLOGO. And for that, we just take the SmartBASIC tape out, put it over here to the side for a moment. Grab our copy of logo, which comes in this nice big binder. This is an absolutely fantastic implementation of Logo that was put together by Logo Computer Systems Incorporated. And LCSI did a number of Logo implementations for all the major microcomputers, including Atari, Apple, Coleco Adam, and IBM, others. And the version that they did for the Coleco Adam was fantastic. Start by basically taking the Coleco Adam data pack here, the SmartLOGO data pack, and throwing it into the drive and pressing the reset. And it looks like this particular tape, every time I put this tape in, sometimes it comes in a little sideways, so I have to reset it. Now I'll just take and redo it again. Give me just a moment. For some reason, this particular tape doesn't want to So it's not that big of a deal. I take and set it directly into the drive like this. It was because I had a floppy in the drive. Move the floppy, just kind of let it sit out, and there we go. So now we're booting into SmartLOGO here. You can see it's rewinding to see another part of the tape. There it goes. And yes, this is literally how long it takes to load various programs directly off the Adam. And it's one of the reasons why I tried to make this video, so you can actually see what using this is like. Coleco also took and provided copies of all of these programs on disk format as well. So you could get them in disk format basically by sending off for a disk copy with proof of purchase of your original data pack. So here we have logo here with our friendly little turtle, which is our drawing implement in front of the screen here. And it's doing some loading of additional logo procedures in the background here. And it will ask us in just a moment whether or not we want to use tutorials. And we can, if you want to. There are some nice step-by-step tutorials that you can use to learn the language here. We don't need them here. I will do my own thing. Now, it's worth noting that the documentation for this particular program, this particular language, is absolutely amazing. It's divided into a couple of different sections. There is a section called Turtle Talk here, which is the primer, which gives you tons of wonderful examples on how to draw shapes with the turtle, how to do complex things with the turtle, and so on. It's absolutely freaking gorgeous. In fact, I'll take and zoom in just a bit here so you can see. This is, ironically, it's the same typography and manual layout that I saw also in the Atari version of Logo as well, which makes sense. It's the same company that did both of them. And there's tons of wonderful bits of code here. There's also, in addition to Turtle Talk here, which is the primer, you also have the reference manual, which takes and provides all of the a comprehensive reference for the entire program. And even the reference has tons of absolutely wonderful examples. This is one of the best versions of Logo I've ever seen for a particular. So with that, we'll just kind of keep this to the side right here. Let this guy just kind of be. And we will switch back over to the main screen. I will turn off the overhead here. Logo is a language that was developed by Dr. Seymour Papert for the purpose of teaching children complex concepts in mathematics through interacting with a computer, and as a side effect of that, also teach them the concepts of computer programming. And it does this by implementing a language that basically is derived from the Lisp programming language, but without all the parentheses. Now, normally, to start off with, Logo is extremely interactive. So commands that you type are immediately executed. If I do HT, that hides the turtle. ST to show the turtle. If I want to take and clear the screen, that's CS. So on. The turtle is actually implemented as a sprite on the Coleco Adam, and you can have up to 31 turtles corresponding to the 31 possible 0 to 31 possible sprites on the display. It's not quite 32 because I think one of the sprites is actually reserved for internal use. So to start off with, we can do simple things like maybe we want to take the turtle pin is down. So if we do a forward of 10, turtle moves forward a little bit. And if we do right 90, well, that turns 90 again. So forward 10, right 90, forward 10, right 90, forward 10 again. We've drawn ourselves a very small square. And if I do home, it puts the turtle back in the center of the screen. Again, I can take and do CS to clear screen. Everything's nice and clear. Using it interactively like that is great to start out with, but things really start coming into their own when you start adding additional words to the language which do things that you want to do. For example, if we wanted to take and not have to type out that sequence of commands to draw a square, we could do this, to square. And now we're saying, okay, well, how do we square? We go ahead and we repeat the following sequence of commands 4 times. We'll say forward 50, right, and go right 90 degrees. And when we're done entering a new command that we want to use, we press the 6 smart key to define the command, and after which case we can use it immediately. And we'll see right here, we just defined a new command to draw a square. Cool, huh? So, funny thing, any commands that you create, you can take and use them in other commands that you also create. Let's say, for example, we want to do kind of a star-like spirograph pattern using the squares that we just made here. We can. I'll take and clear the screen here, and we will do to star. And we'll do kind of the same thing here. And we'll repeat the following sets of commands 30 times. Square. But after each square, we want to take and turn right by 12 degrees. We want to turn the turtle right by 12 degrees. Go ahead. Okay, we're done. We press the 6 key to define. And now, when I do star, we can see that we've created a very complex spirograph-like pattern very quickly using partially the square command that we just made earlier. But there are other things that you can do as well. Go ahead and clear everything out. And logo can be used to a great extent to explain complex ideas in mathematics in a very simple way. Dr. Papert used to have an exercise that he would do with 3 different sets of children. The first child would be about 5 years old. The second kid would be about 10 years old. And the third kid would be about 15 years old. I'm only going to describe the efforts that he does with the first kid. So with the 5-year-old, he basically takes the 5-year-old kid and asks him to cover his eyes. And he says, okay, now that you've covered your eyes, I want you to walk around in a circle. So the kid takes and walks around in a circle. And while he's doing that, Dr. Papert would stop him in the middle, and he would say, what are you doing? How are you doing this? How are you walking around in a circle? Well, I'm moving a little bit and I'm turning a little bit. Okay, cool. Can you do that in Logo? Yes, we can. Simple. Can you do it like this? Circle. We repeat the following 360 times. We go right 1 degree, we go forward 1 degree. So we turn a little and we move a little, and we repeat until we have completely done the circle. Press the 6 key here to see this defined, and if we run the circle command here, we find that the turtle has absolutely no problem drawing an absolutely perfect circle by moving a little and turning a little. And this is very important because what the turtle has just done here is analogous to integration in calculus. So you have now given a 5-year-old kid an intuitive sense of understanding of the concept of integration in calculus. Even if he won't use that knowledge for quite some time, he will recall it when he goes to do his calculus much later. I think that's pretty much it for Logo here. We'll take and move on. We'll go ahead and take our Logo cassette here, data pack. I keep wanting to call them cassettes too and tapes, well, because, you know, they look like them and they're shaped like them. We'll take it, put it into case, put it into its little holder here, and we'll put this off to the side. Move on to our next piece of software. Our next piece of software is AdamCalc. AdamCalc comes in a binder much the same like SmartLOGO. And AdamCalc, quite literally, is a spreadsheet program. The spreadsheet program, if you're familiar with Lotus 123 or Excel or any of a number of different spreadsheet programs, that's what this is here for the Adam. We take it, put it in the drive, make sure that the disk drive is open here so it doesn't override, and we go ahead and press the reset key here. I won't show the loading process for these or any of the other tapes from this point forward, since I think we've done that enough. Now, we've seen, as a result here, this boot up splash screen here, which is showing a hardware inventory of my Adam right here. It will show up to 2 disk drives. It will show up to 2 data pack drives. It shows the 64K RAM expansion, the printer, and the keyboard. Now, AdamCalc will actually use the 64K RAM expansion, not for storing larger spreadsheets, but to store a print buffer so that you can continue working even while a particular sheet printing on the printer. Do we desire AdamCalc's online help feature? In this case, yes, we do. So we go ahead and press the 5 key here. And we are inside of AdamCalc. And AdamCalc really is a very straightforward spreadsheet. We can take and press the question mark key for help, and we can see the different categories of help, such as the command list. So you can see what each bits and what each function actually does, digging down into it. But also we can see function lists, so you can see the different types of functions that you can do inside of AdamCalc as well. It's got a mixture of financial and scientific functions that you can use to your benefit. So I'll go ahead and press, go ahead and press escape to come out. You can move up, move down, do your manipulations right here. Let's say enter in values. By default, it does dollar values. Oop. Okay, sorry about that. I think I got the nomenclature wrong. Let me double check. One of the nice things here is that there really is excellent documentation showing not only how to use a spreadsheet, but also how to use AdamCalc. And if we take and go into the overhead here, you'll see that it's going through and brings you a detailed tutorial showing you how to take and enter in things like data, how to enter in formulas, cell references, and the like. And it turns out I was using the wrong cell format here. I was thinking about multiplan. Give me a second to. It turns out using cell references are done in brackets, and rather than using letters and numbers, they just use pure numbers here. So we'll take, and column 4 here will have the sum of 1, 2, and 3 here. There we go. And as we change values, of course, it will take and update the value over there as well. So there you go. But we'll open up a more complicated example here. First, we'll take and press the clear key to take and clear this out. Blank sheet. Go. And then we will go use get again, and some of the demonstration files that we have on the tape here, we'll see that it sees both our floppy drive. Again, we can use our floppy drive here on inside AdamCalc, but we can also use the data pack drive. We use forward to drive 1, 6 there, grab the directory, and we will grab a copy of the loan schedule. Select it. Done. And we'll see here that, yeah, we're basically loading in from tape again. And one of the things that's happening here, it's loading this in, parsing the data, and then loading some more. And because it's doing that, it actually has to reposition the tape and rewind ever so slightly to load the next block. The loading inside of AdamCalc is a bit slower than another. So you can see. And as we're loading in, we can see the cells counting down. Should be hitting the bottom here. And you can see this particular spreadsheet is taking up almost all the memory. And it takes a moment for all of this calculation to happen because it's actually doing a loan schedule amortization. There we go. You see it took a minute for this to actually load in, but we can see right here that we have a loan amortization here, starting with a principal value of $4,000 over 24 months. And split off into principal payments, interest payments, remaining balance, and so on. And as we take and change the principals amounts that we have here, we'll see the chart actually update itself. And we want to take and change that to 12,000. We'll see a calculation, and in a few moments, we'll see the updated figures. Not the fastest spreadsheet in the world here, but it was meant to be simple and functional for family use. But it does work. There we go. We see our updated values and so on. And to give a good indication of what this actually looks like on the printed output, if we were to take and press the print key and to actually print out the values and whatnot, I'll switch over to my overhead camera to a pre-printed copy that I did earlier. We can have a nice little look here. You'll see it's actually doing a pretty darn good job. It was able to take and use the letter quality output of the daisy wheel here to its advantage to make a really nice looking spreadsheet. In fact, I'll take and switch over to the handheld. See it better. Apologies, I am having to do lives. Do some patience. You can see the output of the page looks quite nice. It's nice and quality, and overall, very well done. Here we go. We'll go ahead and move on to our next program. Actually, one last little bit of information before I move on to our next program. AdamCalc will support a maximum of 255 rows and 255 columns, or however much space you have left in memory. And well, there's also a calculator applet as well. You can use by pressing the wildcard. We'll go ahead and get this put up here and put on our next application, which is SmartFILER. SmartFILER is a database application. More specifically, it is an indexed database application. ISA. In technical. So, go ahead, tape out here, drop it into its case in its little sprayer. Put AdamCalc to the side while I take we have right here SmartFILER. SmartFILER is, like I said before, it is a database meant for home and family use. Open it up here, see some nice little bits of documentation, including a little cheat sheet right here, quickly showing you how to use the various portions of the system. How to search for things, how to load things. And we have the main manual right here, which provides the comprehensive reference that you need, and as well as walking you through how to build a new database by building its forms and so on. So we take a look, we can kind of see fields here for forms, what types of forms you can create, such as character fields, numeric fields, and searchable non-text fields, that sort of thing. And it even gives you some example forms here that you might want to use in your first database, such as keeping a record of books, entering records into database, and so on. Now, for this next bit here, I have here the SmartFILER here, but I also have a copy of what is known as the Adam hardware database, which was put together by a particular user group in the late 80s, early 1990s, and uses SmartFILER here. We'll use this as our SmartFILER dataset. Start by pulling our SmartFILER out, putting it into the drive, closing it up. Put you right there, and booting the system. Go ahead and get rid of my overhead view here. And we boot into SmartFILER. So now SmartFILER is here, and we get the opportunity to take and pick insert our data pack. Here, take our data pack. This is an example of a data pack that was put together by a third party. In this case, this is one of Millie Hicks's data packs that he repurposes from a Sony HF60 tape, drills additional holes in the back here so that it will be in the right place, drills the necessary holes for the alignment, and ultimately uses a duplicator to take and copy an existing data pack's formatting onto a blank data pack. And they work pretty well. Oh no. But the tape has been modified. We'll put the tape in the drive here, and we will select drive A. And we'll see right here that, yep, we are cycling through, we've opened the database, it's now ready to go. And now we can, for example, go and look for an index of records or find records, that sort of thing. Let's go ahead and see if we can find some records here. And I will look for a particular item. In this case, drive. And from Coleco, we'll go ahead and press 5 to start search. Now at this particular point, it is searching on the tape, on the data pack, looking for the data. Oop, no records found, so it looks like I just typed it wrong. No big deal. We'll do that again, and this time we'll just look for stuff by Coleco. "61 records found, 20 may be displayed." We'll go ahead and see the list. These are the top 20 entries for hardware items by Coleco. Again, it's having to look through the index, read the index into memory, and then display it. It's cycling back to the middle of the tape. And you can definitely see why using a disk drive here would be much more faster. But I did want to do it in this manner to really show the point that yes, doing it via a data pack was doable. Bouncing through, searching through, doing its thing. Rewinding. And you can hear, I'll go ahead and turn on the microphone. There we have a number of matching elements here. There we go, data drive. We'll go ahead and display the record. And the record's in memory, so it just shows us. Finally, I'll go ahead and end this particular demonstration of the database of SmartFILER here by opening up the form. We'll go ahead and hit 2 to design a form. And right now it's closing the database so it can reopen it in the forms. Okay, so insert program tape to continue. Problem? Head. Go, and press the 6 to continue. Okay, insert data pack. And we will dispense with this. So we will take and modify the form, and we can see our schema for the hardware database looking at. We can see right here that we have, each one has a field name. We have a type, which corresponds to either character or numeric, or a T field, which allows you to have up to 2 pages of typed text. The difference here is that we also have what is a field length, and the total length for all fields cannot exceed 256 characters. And only the character and numeric fields can be searched, and the text fields cannot. The text fields are primarily there just to hold notes, but they cannot be. But really, that's it in a nutshell right there. This is the database. Very, very simple, very straightforward ISAM type database. But it's adapted for a number of other uses as well, which we'll see. If I take, and for example, we'll go ahead and put you back in our little folder here. And we'll move on to our next little piece of software. SmartFILER, the data type right here. And we will up RecipeFILER here. SmartFILER. We have RecipeFILER. RecipeFILER also uses the SmartFILER technology as well, but adapts it specifically for storing recipes, adding things to a shopping list. A very nice piece of software, very simple and straightforward to use, and it comes with 30 example recipes on the RecipeFILER data pack itself to show you how to use the program. Again, like every other Adam program, we just take the data pack out of its shell, pop it into the data pack drive, and we just hit the reset. Oop, and I had the floppy disk in the drive here. Get that out one more time. I mean, here we go. You can kind of hear Here we go with the RecipeFILER being loaded in. Nice little splash screen here. So here we go. RecipeFILER here, ready to go. All we have to do now is I want to pull my recipes from the tape drive, drive A. Press Smart key number 3. Here we go. And now we can, of course, take and pull out, look at the index, and we'll use the index to take and retrieve a recipe here. In this case, we'll take a look and see what we have on file here. We can look for specific recipes that we want to index for, or we can just see everything by taking and pressing C index. Again, we have 30 example recipes that come on this data pack that we can quickly look at. And I'll pull beef stroganoff. I had that yesterday. Oh, feels good, yeah, absolutely. Here we go. Display recipe. There we go. Oh, here it is. We have the recipe here. We can take a look at it. And of course, we can press the print key if we want to take a look. Okay, bam, here we go. Recipe, directions, that sort of thing. And of course, we can take and use the print key to print a copy. And what actually comes out of the printer looks a bit like this. Nice printed copy of our recipe right here. It's gorgeous, doesn't it? Absolutely freaking awesome. So there we are. Taken our recipe, looked it up, cross-referenced, etc., printed out, nice piece of paper here. That's RecipeFILER in a nutshell, with one additional feature which I will quickly gloss over here. And that is that in addition to having the recipe view here, you can copy ingredients into the shopping list so that you can use it for shopping for your groceries, for your recipes. There you go. Awesome, isn't it? That's RecipeFILER. Moving on. We'll go ahead and put the RecipeFILER data pack from here into its case. Close the binder here. And we'll move on to our next program, which is SmartLetters and Forms. SmartLetters and Forms is basically a templated letter writing engine or word processor writing engine where you can basically take a template of common things that you may need to write, such as a resume or an acceptance letter, fill in the bits and pieces, and then print out the results immediately. Again, function much like the other programs here. You get a very basic program here showing you how to use the particular programs, which we'll dig into when we actually load it. Get your SmartLetters and Forms data pack here, which you can take and, like everything else, put into the drive, into your data pack drive. And immediately boot into SmartLetters and Forms using the reset. So once we've actually done this here, we start off with a blank sheet of paper, much like we do in SmartWriter. And in point of fact, it actually takes and uses much the same code that's in the SmartWriter ROM and just repurposes it for this program. And we will take and pick a particular category of templates that we want to use. Say, for example, we want to use personal and business, so we use Smart Key number 3. This will show us a list of potential templates that we can use. We'll select cover letter with resume, sure. We'll press Smart Key 5 to get the result. And yes, it's reading this off the tape, but here we go. Now that it's here, you will see our form letter here. And we can scroll down, we can read it. Now, this particular program runs in moving window mode only. It doesn't use the roller mode, SmartWriter. But this is primarily so that it can actually show how this is going to be printed on the printed page. See how this is actually going to fit together. And at any time, we can move close to a field and we can hit the tab key to enter in the relevant pieces of information that we need to enter, such as sender street, city, state, and zip, like for addresses. We hit the tab key, and we got sender street. Say 1, 2, 3, 4, yeah, whatever. Maple Drive. And we hit done. And it has inserted that in for us to use. We hit the tab key again, city, state, zip. So, Denton, Texas. We hit done. And we fill in each of the individual pieces of information. We can also hit tab to go to the next field, and so on until we've entered in all of the information in our forms. But we can also take and do a sample output as well by pressing the sample key. And you'll see very quickly that all of the form entries are replaced with example information. And you can see the result. And if you want to see what one of these actually looks like, we'll take and flip over to our overhead view. But let me grab it quick. This is a thank you note from the thank you template here. And we'll just take and pull over to overhead. Look. So you can see right here, basic thank you note template. Go ahead. Now, bloop. There we go. A nice little thank you letter ready to use. And that's really it. That's the smart letters and forms right there, all in a nutshell. Nothing too terribly earth-shattering there. That's simple, straightforward, easy to use. Go ahead and put smart letters and forms into cassette shell. Put the cassette shell back into our smart letters and forms here. Close it up, and we'll move on to the next thing. I think we've done all our productivity applications. Let's see what the next thing. Oh, okay, so it turns out there's one more productivity application we needed to cover, and that is the address book filer and auto dialer. And I don't have an original for this one, so it's on a data pack copy here. And you'll see this is another form of Coleco data pack here with a full front label here. So you can put that in. We'll hit the reset here. Oop. Actually, you know what? We'll skip over the address book. There were actually a number of educational titles that were available for the Adam as well, and things to help with school and whatnot. And one of those particular pieces of software was called Flashcard Maker. Again, I don't have an original of this. I'm literally just using a copy. So we'll just take and insert my copy here, which I made using the Coleco tape utility. And there's no copy protection on any of these titles, so you can literally use a piece of software like Coleco tape util. They can make block for block copies of these particular programs and use them. So we'll take and put it in here. We'll hit the reset here. Okay. Again, much the same here, electronic flashcard maker. And this literally allows you to take and make electronic flashcards. It's kind of just a riff on the database project here, except we're doing kind of a card file. And it's presented in such a way that you can do time drills on the pretty useful little educational. Again, help little Billy learn his multiplication tables or learn history facts and so on. While this is loading here, I will put it up. And we can see here, Coleco presents the Flashcard Maker. Now at this particular point, we don't have anything loaded in, so if I take and push 6 to use cards, it will tell us that there's no deck in the Adam, but we need to make one, or we need to get one from, we need to take and get a deck loaded in. So to do that, we will actually take and use the, we'll take and use the store get key here too, and I will get a deck pressing number 6 here. We'll load it from drive A, and there is an example deck of cards that we can load in that shows how the program works. And we'll load in the sampler pack. So get cards, press 6 again. Again, you know. And there's the sampler pack loaded in, ready to go. Okay. And we can go ahead and use those cards again by pressing 6 here. And we have a way to set a number of different options. Say, for example, do we want it timed or do we want it manual? If we want it timed, how long do we want to show each part? The front 0 seconds, back 0 seconds. We use the arrow keys here. Say, okay, I want to show the fronts for 5 seconds, and I want to show the backs. Press the 5 key, show the backs for 5 seconds. Press the 6 smart key, done. And do we want to do them in order, or do we want to do them random? Do we want to save the misses? Well, that sort of thing. Okay, great. So just hit play, okay, start, and we can basically do, okay, we can either choose to edit the cards here if we want to directly, or we can start to use it. Match city to bull, okay. Don't really know, but it will show us the answer on the back of the card. Okay, great. And then so on. Move to the next one. Colorado is known as the Centennial State. Well, this is true. Okay, great, boom. And so on. And you can go through the process of taking and learning these particular flashcards, and when you want to take and use them, then you can start entering in answers. So on and so on. Pretty simple and pretty straightforward. Okay, we're done. I didn't make very long, so I didn't make very long to actually be able to enter in answers here, but it keeps track of how many cards you got right, how many cards you got wrong, so that you can track your progress. And that's really it in a nutshell with the electronic flashcard maker. Coleco made a number of flash packs for different things, such as a vocabulary builder, one for American history, and so on. And of course, you can make your own. And that's really the other thing, too, to understand You have, in addition to these pre-formatted data packs that have applications on them, Coleco also sold the pre-formatted data packs themselves, which all kind of had, here, if we go back to our overhead, you can see that these are blank right here, pre-formatted, and you can take and use them for your own purposes. They're all pretty much, for the most part, interchangeable. And of course, there's information in the document links on how to make your own data packs as well. Moving on to our next program, we have what is called ExperType, which is a touch typing program. And this is another one I don't have in an original form, so I made a copy. Much the same thing here. Pop it in, throw the data pack in, press the reset key, and Bob is your uncle. Looks like, thinking about this. Okay, so please type your name and press return. Now for this, I will take and have my little overhead view here in a window so we can see. Great, that, and while this is happening, here we go. Hello, I'm your instructor, so on. And this is basically a touch type exercise. It's pretty, works pretty well. Each one, it starts by showing you each individual character and placing your hand on the key. Okay. On. Then we wait for the home row keys, okay, and then we go from that point. And as it does each one, it will take and advance the roller. And so on. As you make a mistake, it will take and highlight those mistakes. As you can see right there. And so on. And of course, you can take and advance to the next lesson, advance to the next lesson as you need to. So there you go. A simple little touch typing tutorial. ExperType. Moving on. For this next section, I'm actually going to be comparing. Now we actually get to the games. And I'm actually going to be taking and starting off by comparing one of the super games that I have with one of the cartridge games that I have. In this case, it's Zaxxon. We're going to compare the original version of Zaxxon, which is on cartridge, to the SuperGame, which is actually on floppy disk. So you'll actually see a game actually being loaded from floppy disk here. But I will go ahead now, and we will first grab our Zaxxon cartridge, first and foremost, and I will insert the Zaxxon cartridge into the cartridge slot. This can happen while the computer is actually on. Once we do that, okay, fine. We take and hit the cartridge here, and we see that we boot immediately into Zaxxon. We are now in ColecoVision mode. A little pause later, and we find ourselves at the skill screen right here. Now, for this next bit here, I'm actually going to go real quick to my overhead, and we're going to plug in my joystick. Plug in my joystick. One. Have our ColecoVision joystick here, which if I take and go back to my Adam, hit my overhead here, you'll see that if I take and press skill 1, we find ourselves immediately going into the game. And this will be rather interesting trying to play with frame buffer lag here. As you can see here, even at this particular area here, the games look absolutely fantastic. And it looks an awful lot like the arcade. It plays very well too. It's absolutely fantastic. The job that was done to really make this play well. Like I said, this is going to prove to be rather interesting to try and play because I don't have any pass-through. And I actually prefer to use my gamepad here. I'm using the real Coleco joystick. But the games look absolutely fantastic. And you'll see this particular game, they managed to do an excellent version of Zaxxon. In this case, RAM and about 16K of ROM. Absolutely fantastic. Just, it feels well, it plays well, it does a darn good job. Now, let's take and compare and contrast this with the Adam version. On my copy here, I'll actually show my copy on disk. So we'll take, I was on, but the disk that we have been using on the side here. We'll grab my floppy disk version of Zaxxon. Great, isn't it? Okay. So, pop it in the drive. And ironically, I can just keep this cartridge here. It's not going to affect anything because when I push the reset on this side, it's going to reset the system in Adam mode, and the cartridge slot here is basically going to. But we will see now if we come back over here, it's already gotten to the splash screen. It's loading the game, and the game is loading up very quickly. But first thing that you'll notice almost immediately is that it's saying there's a game saved on this data pack. So do I want to take and play it? Well, I can. If I take and hit 2, it will literally start up where I left off. Sure, why not? We will load the game. immediately get back to Flash. We'll go ahead and pick one for new game, Star Warrior here. And one of the nice things that happens with this particular game is that it's streaming the game off of the disk as you're playing through it. Because, again, as I mentioned before, there are separate I/O processors for AdamNet devices. They can take and load data in from disk. The main CPU can ask for the disk drive to load blocks into an area of memory and do that entirely without the intervention of the CPU. You can see already that the game is fundamentally different, more detailed, but you also saw that you had the ability to take and save your position. And also definitely more levels, more games. Just overall, a much larger gaming experience because it can load parts of the game in as it needs them. Getting better. We'll play through this. As soon as we play through this, I'll show you the next piece once we actually finish playing the game here. Words cannot describe how much I actually enjoy using other joysticks for the ColecoVision. I do not enjoy using these at all. As you can see, a wonderful experience is like the arcade, which is what was ultimately promised and ultimately delivered by Coleco. Scripts here, and items here. I'm just going to play just enough that we can take and get through. All of the major stages for the arcade game are actually present in the Adam version. Whereas in the ColecoVision version, it's only most of them, and even so, even in somewhat truncated form so that it can fit into a 16K card. But here on the Adam, we have the whole arcade experience in the game. And right now the disk drive has just kicked on because it is loading the next portion of the game as we're playing. The nice thing I like about the Coleco games too is that skill level 1 actually gives you just enough challenge for people who aren't very used to the game to be able to get used to the game quickly and not be too difficult to play. Here we go on to the next phase, and this should be Zaxxon. Yep. Darn. Didn't quite get it, but at least I got his product. And now we get to the big boss here. The disk drive is coming on again, and it's loading the next piece of the game in the background as I'm playing here. going to guess that this particular disk has an issue. Yeah, because right now it's acting like it can't read the disk right here. So I'm going to have to take like this. We will have to cut this a little bit short. That's okay. We can take and press the reset on the cartridge here. And I will take the disk out, turn the disk drive off for a moment, and we will go on to our next game here. Our next game is actually going to be a copy of Buck Rogers' Planet of Zoom. This is the pack-in for this system right here. That insert it in. Hit the reset lever. Go back to the Adam here. And of course, it is loading the tape. Here we go. Woohoo! The game packs are actually stored in a slightly different manner from the other tapes that we've seen before, in that block 0 is always at the very beginning of the tape rather than at the center of the tape. Hence the term right directory pack instead of a center directory. But you can see right here, it's just loading the data into memory here. And what's actually happening here is that, again, this is all happening DMA. These splash screens are waiting for the game to finish loading. And at any given time, I can take and press, I can go ahead and start the game by pressing a key here, one player, skill 1, and as the game is doing its thing, it will start to load the next bit of information as the game is playing. And you can see it right there. Okay, we'll go ahead and kill that, and I will actually play through this a bit. That's it. Play. Fire button. Fire button. Now it has shifted to play the next set. This has all of the stages of the arcade present as well. So while this has happened, now it's flipping over, and this is about to show a major feature of the SuperGames that are exclusive to the SuperGame, and that is essentially a high score table. Again, we're loading in the high score table here. And we get the opportunity to take and enter in our name with our joystick. We can't use the keyboard, which is unfortunate, but that's okay. We just use the joystick to select, enter our full name in, use the other joystick button to scoot forward, press the done, and it writes the result into the high score table. There for everyone to see. And on devices like the FujiNet, we've actually taken and leveraged this so that we can have internet-wide high scores that are shared and seen by everyone. There we go, there's Buck Rogers. And we'll move on. I'll go with the Adam version of Donkey Kong. of Donkey Kong, I'm using repurposed Buck Rogers tapes to take and hold these games, again, because these tapes are in write directory, more efficient for this. So, pull it in, hit the reset, and load the game. And you'll see that Coleco's did a lot of work to make this efficient, this format work well enough on tape. And you're seeing that we're loading these games from tape, and it's doing a pretty darn good job of it. Press the keypad, okay, 1 player skill level, and now, again, as this intro screen is happening, it's loading the next stage of the game into memory, doing this in the background. And it's loading more data in here. But there we go. You'll see if you're familiar with the ColecoVision version of Donkey Kong here, it plays a little bit differently. But it actually has all of the stages. With all the correct graphics, unlike the ColecoVision. Now the typewriter kicked on again. It's loading the next. But even though the typewriter is doing its thing, I'm still moving around and playing the game. Ow. Workplace safety is not funny, guys. Watch out for psychotic gorillas. Oop. So, I mean, there you go. The one thing I will say about the Adam version of Donkey Kong is that all of the stages are there. And it's one of the few cases of home computer ports of Donkey Kong or the NES version where all of the stages are actually present. And that is in the Adam version. And present with all of their ins and outs. Whereas on the ColecoVision version, it gets close, but some bits and pieces are missing, such as the floating hammers in the hammer. That is the bouncy springy hammer piece that you have to dodge. Overall, I mean, they did a really good job. Again, and it's loading the next stage here. But you see that the tape drive and everything is loading all the levels and all the data dynamically, but it's not affecting how we play the game or how we perceive the gameplay that at all. I mean, honestly, I would say you really don't notice it. Oop. I want to see if I can get to the hammers at least so you can see that, and we'll take and bounce to the next game. This game is actually a very good example of the built-in graphics and sound routines that are part of every ColecoVision in the form of the OS 7 ROM. And those things actually provide a huge object-oriented graphics and sound subsystem that all the different games could actually use and we're able to cut development time down considerably. I'm not going to be able to do it, but I will try. It's weird because, again, I'm playing this through a capture device where there's a latency involved. Here we go. Get to the hammer level. Is it a hammer or a jackhammer? I literally forgot. But you can see them right here. Implemented as sprites. And you can see the drive is kicked in again. We're loading more information for the next level. Gotta keep moving. Alright, well, I think that's good enough right there. We'll move on to our last super game that we're going to show here, and that is Donkey Kong. I went ahead and hit the cartridge here so that it would just show the ColecoVision screen. Give me an opportunity to take and switch the game. Take this, okay, great. Take that away. End off with what is quite possibly one of the best ports of Donkey Kong Jr. that I have ever seen. And the difference between this and the ColecoVision version primarily is, again, you have high scores, and again, the game has, all of these games have high scores. They have the ability to save high scores, but they all typically have all the levels. The levels are there, pretty much there to play them. So we go ahead, hit the reset. Go, let it go. Donkey Kong Jr. shows up in a few moments. Again, these are games, other than Zaxxon, these games are being loaded off of data packs. So here we go again. Pick number of players, then hit the skill level, and we have, unlike the ColecoVision version, we have a full intro screen here, and the Donkey Kong sprite is much larger in this version of the game compared to the ColecoVision version. And again, the game is loading itself up as we're playing it. We're doing a pretty good job here. And this is such a bizarre challenge trying to play this through. Trying to play this through a capture device. Nice thing too, the Adam version has all the animations. 7 has as part of its code is a good sprite multiplexing engine. You can see that the sprites are flickering as multiples get on the same line, but the OS 7 actually takes care of that detail for you very well if you ask it. Again, full animations for the in-betweens. And the tape drive had already loaded in the next level here, so here it is. It's just okay, kicking into the next thing. So here we go. All of the heavy lifting has already been done. Oh! Again, because I'm literally playing this off here. This is probably an interesting challenge again. Trying to do this on a capture device. Keep everything in order, keep all my timing. Let this happen, please just get down. Ah! No! I want to try and get to the extra levels that you don't see in the other versions. Now, there is a 5-stage version that Coleco actually did as a prototype. They showed Nintendo where they added a pi factor. And Coleco didn't like it very much, Nintendo didn't like it very much, so Coleco didn't release it. But it is available, and you can grab it if you have a FujiNet, for example. You can mount it up and you can play it. But the nice thing here, like I said, all of the levels are here, and they're all implemented quite well. This one will take the longest because I really want to show that all of the levels are actually. Maybe not. We'll see. Darn it. He nicked my toe. Really? Okay, I guess this is gonna force the issue here. But that's okay. I will play the best of my ability that I can. Excellent animation. I mean, truly. Let's see if I can go one more cycle. I'll make it to Mario's. just have to do the keys one more time, and then I'll hit Mario's heart. I'll hide out. We can do this. Say, what? Maybe 10 milliseconds? Enough of the lag. It's kind of interesting. Don't take any stupid chances. Just get it done. Here we go. Now we get to Mario's hideout. Okay, so you can see the whole game is here. They did a fantastic job bringing it. It looks great and it plays great. It absolutely feels wonderful. Coleco did a fantastic. How did that happen? Wow! I managed to, like, hit the one pixel where you couldn't hit the key. Wow. Never done that before. Bounding box collisions are just wonderful, aren't they? Not in the bounding box. Here we go. Whoop. And the whole cycle begins again, just like life. There we go. That's the game in a nutshell. I'll go ahead and just die. Oh no! Now the tech drive is clicked on again, and it's going to show us the high score. Now in my case here, I copied this off of the high score enabled data pack that's currently over on apps.errata online on FujiNet, so I copied that to tape. So here are high scores as they were maybe a week or two ago. But that's okay. If I want to take and clear out the high score table, I can do that. Oop, I hit the wrong key. You can hit pound 989 to clear out the high score table, or you can begin again. So there you go. Those are the super games. Awesome, isn't it? There we go. Let's see. Moving on. What's the next thing we got to deal with? The next thing that we're going to talk about is the other major operating systems that we actually have access to on the Coleco Adam, namely CP/M and TDOS. And really, I think I'm actually just going to show CP/M here. TDOS is actually extremely similar, but if we go ahead and insert a CP/M disk in our disk drive here and press the reset, it will actually take and boot into Adam CP/M here. And this is actually a complete implementation of CP/M with a VT52 terminal ready to be used. And thus, pretty much any piece of software that you can use with CP/M on other CP/M machines is also available to be used on the Coleco Adam and will work as is with everything that you need. to actually implement enough of CPM to work here, to complete CPM 2.2 implementation, and the terminal, even though the terminal only shows 31 characters across, you can pan those characters across to be able to see the other side of the screen. So not only do you have a complete CPM environment that is completely compatible with CPM 2.2, this means essentially that you can run CPM applications, like say, for example, a copy of WordStar. It works just fine. Wrong terminal type. I think I loaded the wrong one. Hold on a second. Apologies for that. I loaded the wrong, I actually loaded the wrong, not the wrong disk, but the wrong terminal. No big deal. Just pick the right disk in. And like I said before, it uses the VT52, aka Heath H19 terminal type. And this works in both CPM and TDOP. So you can see it right here, bam. It just works, and we can take and pan across and see the other side of the screen just fine. So we have access to WordStar. We can take and load documents in, do everything that we need. The screen will try and do its best to guess where it needs to pan to, based on where the cursor position next. Yeah, there you go. Bam, WordStar running on your Adam here, and it just works. We'll go ahead and Control KX, save the file out. Okay, great. I think I mounted it read-only. It might have an issue because I have mounted it write protected, but right, never mind. There we go. So there we go. We have WordStar running in CPM on the Coleco Adam, and it handles it just fine. And yes, you actually can. If you really wanted to, you can take and use a digital data pack as a data drive. The advantage of that would be that you have 256K of space versus 160K for the floppy. The disadvantage is, well, it's slower, and CPM really wasn't designed to work well on data packs. So it does a lot of extraneous reading and writing. But all the same, since I booted from disk, drives A and B are the floppy drives 1 and 2, and C and D are tape drives 1 and 2. So I can just as easily take a tape, put it in, and literally format the tape. I'll take and cut this out here since I don't want you to take and suffer all the way through it. Cutting back, we can see we're almost done here. There are 256 blocks in all. And yes, this took close to 5 minutes to complete. It takes quite a bit of time because it has to write the CPM fill byte to each and every single block. XE5. 1,024 bytes of that for each block, 250 times, with all of the overhead of seeking from one side of the tape to the next. And no, we're not going to verify the media here. Format another, no, we're not going to do that, but we'll find now that if we go to drive C, we now have a usable drive here that we can use. And yes, it's going to try and read the directory track here. So it is seeking back close to the middle of the tape, roughly track number, block number 13 on the track on the tape here, and reading that data. So not quite at the center, but close to the center. So now we're logged into drive C here. If we do a directory on this, we'll see that it has no file. And if we do a stat on it, we'll see that we have approximately 241 kilobytes worth of data left put on the pack. Now, to show you kind of how insane that this can actually get, like I said, it's a usable format, but it's not something that you would want to use day in and day out. And we're going to take and just copy one thing to. We're going to use pip to copy pip itself to drive C, and we're going to copy this one file here. So now it's reading the tape, looking to find the next directory entry here. Okay, it's done that. It's now reading from the drive, from the disk drive. Now it's writing to the tape drive. Writing, writing, writing. And reading from the disk drive once more. And there we go. Now if we go to drive C, we'll log back into drive C here. It rereads the directory track. You can see that it's a substantial delay between the time that you do it and when you see it. But if we do a directory now, we'll see pip right there, ready to go. And we can run it too. We'll go ahead and just do that. Now it's speaking, reading the directory. And since the pip file is directly after the directory here, it's going to skip over to the data area, which it just did. Read pip into memory. And see, it's having to seek into a couple of different places. So the tape drive is zipping back and forth, reading blocks sequentially back and forth. And we'll see if we actually, can I do this quick enough? Oh boy. Oh, come on. And you can see right there, it took quite a few moments to take and read that in. So, again, while you can, indeed, use a data pack as a data drive in CPM, really don't want to. Well, all right. I guess this ends basically the demo section of the demo section of the presentation here. And in fact, if we go back to my desktop here, now we actually, okay, gosh, it's been a long day. We have one more set of demonstrations that we need to do here, and this is for the FujiNet device. The FujiNet is a peripheral for your Coleco Adam, and indeed for a whole bunch of other systems that actually takes and provides a virtual disk, virtual printer, a virtual network adapter, and then some, all on a single peripheral. It plugs in, just like the disk drive, it plugs into the AdamNet. And in fact, you now look at our overhead view, we'll see our little FujiNet right here. I have it actually plugged up to the keyboard port right here. And not only that, but it's actually getting all of its power entirely from the bus and doing a pretty darn good job of it here. So we have a connector going here into the import of the FujiNet here, and out goes to my keyboard. Quite literally. So what all can we do? Well, first things first, let's go ahead and just press the reset button on this guy. Let it go off for a minute, come back on, and we'll let this thing boot. If you do a fresh reset, what will ultimately happen is that when you hit the reset on your Adam, it will boot into a configuration program where if you don't have it configured for your network, it will give you the opportunity to select your network. In fact, we can actually replicate this by going into Show Config, and we can change our SSID so we can see it. And we can see all of the wireless networks that we actually have available. I'll take and select it. Select the network, enter my network password, and a few moments later we will be able to connect in to our network. Once we have this, we are presented with a screen that shows us available hosts that we can connect to. Of course, we can take and we can add our own, or we can take and connect to what's already available. And the FujiNet also has an SD card slot on its side that you can access as a host slot to get access to stuff that you have stored on an SD card. So it can fulfill local storage, and it can fulfill network storage. Let's go ahead and select something from the network here. Let's go to Apps, and we'll go to Coleco Adam. And I will pick something to load, anything at all. Let's say, let's actually go, I'll take and pick a game just as an example. And we will go to high score enabled, another high score enabled game, one that I didn't pick, one that I didn't touch on here, but let's say Dragon's Lair. I will take and press the 6 key to boot this because I want this to be mounted in slot 1 and booted directly. We do that, and within a few moments, Dragon's Lair is being loaded off of the internet onto this Coleco Adam here and being booted right in. If we go ahead and see if I it will boot us back into config so that we can do something else. So not only do we support digital data packs and disks in disk format, but we have the ability to create those disk images on the fly here too, so that we can create data disks. And we also even support loading cartridges of up to 32 kilobytes in size, ROM cartridges, 32 kilobytes in size. We'll do that right now by just picking something out of the ColecoVision section. let's say I want to take and go play a copy of Cosmic Event. Okay, no problem. Page or Congo Bongo Cosmic Avenger. Oops. Cosmic Avenger. We'll take and quick boot that. And there we go. A cartridge booted up into the Atom using the ROM booting functionality that's in the FujiNet here. So not only can you load your Atom software this way, but you can load most ColecoVision titles this way as well. Pretty much anything, it will load anything that's not a that's 32K or less. Does a pretty good job of that. With that, not only do you have the ability to do configuration this manner, but you also have a web-based UI as well you can use to configure your FujiNet. So even if you're in the middle of booting something and you don't want to boot all the way back up to config, you can still use the web-based interface to take and mount things into place. And we'll use this opportunity here to take and load a FujiNet specific program to track the ISS. We'll mount it into slot 1 here. Once it's back at the main screen, it's ready to go. Now, all I have to do, go back to my Atom here. And boot. And this is an example of a FujiNet enabled application. This is the International Space Station Tracker. What this is actually doing is it's calling a web endpoint which reports the current position of the International Space Station as a JSON document. The FujiNet parses that JSON document, and the Atom asks for the pieces of information that it needs in order to take and do its display. Pretty simple and straightforward. There are many other FujiNet applications as well, with all sorts of crazy little things that you can tweak. So let's take, for example, and we will load something else. Go back to here, Atom, go to plays, go to, maybe we want to take and pull the latest news. Well, we can. Let's do this. Boot. Go into Atom here. And maybe we want to pick up the latest news, top stories. Take a look and see what comes back. So we have a list of articles that take and match, no problem. We can take and select them, or we can go back to category. Turn, and we get our news article. And so on and so on. So these are some of the examples of some of the applications that have been written. There are also multiplayer games and whatnot that have been written as well, all to take advantage of the networking capabilities that are on this device. Not only that, but this device can also replace your Atom printer, especially if you have an external power supply, and provide a rasterizable PDF that you can take and use. Good example of that, for example, say that we use the RecipeFILER. We saw the RecipeFILER printout from before. Now, if I take and bring up the output from RecipeFILER, that same recipe that we were looking at before, We absolutely could do that. Or, actually, I thought I had it. Well, let's take a look at some program listings. Basic. There's the sine wave harmonic plot from earlier, and you'll see that it uses the Daisy Wheel printer font here. It renders out to a nice PDF that you can use to print to a modern printer. And it does this extremely well. So on. So not only do you have virtual disk, but you have virtual printer as well, and you have virtual network device, all in a single self-contained little device here, and actually doing an absolute bang-up job of it, to say nothing of the least. Now that we're done with the demonstration portion here, we can actually start to focus on some sections that actually need more detail. Less demonstration here, more explanation, but I wanted to try, there were certain sections of things that I felt needed to be covered better and in more detail. For that, we'll actually switch over to my desktop display. Starting off with, we have expansion. Starting off with storage options. Now, we've seen the use of DDPs throughout this entire demonstration, and these are the standard bits and pieces that are actually available for use on the Coleco Adam. And really, to bring the point home, they're all very block-oriented, meaning that the tape is divided up into a number of blocks, typically 256 of these blocks. These blocks are 1,024 bytes in size each, provide a total of 256 kilobytes of storage. The tape device is very high speed, basically operating at 20 inches per second when reading and writing, and 80 inches per second while searching. I have that backwards. We don't want to leave a tape in the drive, and this is because the read and write heads on these tape drives are not protected or buffered by any circuits like a transistor diode combination to prevent power transients from reaching the tape heads when the system is first powered up. So whenever you don't need to use a particular tape, take it out of the drive. When you turn off the system, make sure tapes are out of the drive. And then before you power the system up, make sure that you don't have anything present in the drive. DDPs come in a variety of different formats, and basically this refers to how the individual blocks are laid out in the format tape and the format track that's right next to the data track. For games, this is the write directory track, and these are called GW format tapes, named after the engineer who did them. I forget if it's Greg Wheeler, the one who did this format. But block 0, as you can see, is at the beginning of the tape. All the way to block number 64, all the way to block 128 on the front side of the tape, and then blocks 128 through 5 on the back side. This particular format is used by SuperGame, Buck Rogers, Donkey Kong, Junior Dragon's Lair, etc. And this format is extremely efficient. There is no file system on these particular tapes, so there's no directories that you can list, whatever. The makers of the individual developers of games use a small bit of tape utility code to basically take and load in sections of a game as they're needed, as overlay. Other than that, there is no file system. The other major format is what is known as center directory. And the fundamental difference here is that block 0, the very first block of the tape, is actually in the middle of the tape. This is also called HE format, after the engineer who implemented it, named Howard Eggleston, who is actually still active in the Adam community today. You can see on Facebook. Block 0 is in the center of the tape, followed by block 1, which is typically the directory, and then you have data blocks after that, typically. You can have more than one directory block, but it really depends, typically for tape. So this is done to basically facilitate faster directory block access, because these tapes actually contain a file system. File system is on block 1 of it. This is used by tapes like SmartBASIC and RecipeFILER, SmartFILER, Flashcard Maker. All the tapes, SmartBASIC uses it. All these different tapes that need a file system will use this layout of tape. And it's important for this distinction here because the layout of a tape is determined at the factory, so to speak. The block layout is pre-formatted and laid down on the tape, and you're just using it. There is no fundamental way to format a digital data pack. Not there, it's not on the menu. The only way that you can apply formatting to a tape is to use either a donor tape or to use something like MAME's cast tool, which I will explain. Thing about DDPs versus standard tapes. The holes are all in a different place. That's the big thing I noticed. I noted that earlier. There are much tighter mechanical tolerances on these tapes. If you take and you spin these tapes with your fingers, you'll find that they're much smoother on travel because the rollers and whatnot are pre-lubricated. And the other major thing that you'll notice is that the cassette shells feel a bit thicker. And this is quite literally so that it can withstand the higher thermal tolerances that need to happen because the tape is moving at a much faster speed. But with that said, you can still adapt standard tapes. You can use 60-minute type 1, that is ferric oxide tapes. All you really have to do is drill the alignment holes so that they can fit in your data pack drive, and then you can use a copying implement, like say a Tri-Sid Megacopy, or dubbing using a standard cassette tape, or using MAME cast tool to make audio tapes that you dump. And in point of fact, if we actually take and look here, we can see all we really have to do to make a blank tape using cast tool is to create a blank image, and then we use cast tool and this command line here to basically read in the image, and it outputs a WAV file that we can take and record to tape using something like Audacity. That's all we have to do. It's really great in that regard. We saw a bit of floppy disks. Basically, all the software on DDP is also available on disk, with capacities ranging from 160 kilobytes or the standard Coleco disk drive here to the 1.44 megabytes for devices like the later Micro Innovations 3.5-inch disk drives that also connect up through AdamNet. All these devices basically, as you saw earlier, you saw me connect up that disk drive, connect up through the AdamNet. Just loop them in your daisy chain somewhere and set the drive selectors wherever it needs to go. Drive select 1, drive select matches AdamNet. We saw booting Zaxxon earlier. There are also hard disk solutions, believe it or not. And these hard disk solutions, actually, you can get them today, and they correspond to IDE adapters that you can grab, and they fit into slot 1. And they provide the IDE connector that you can use to basically basically attach a modern IDE drive or a compact flash solution, whatnot, and have a high-speed hard drive that you use to quickly take and manipulate things on the hard drive. In fact, I can show a little bit of it here. manipulation, go ahead and just do that. Be a moment. This is set up correctly. Deleted it. Here we go. There we go. I had accidentally did the driver. There we go. So we basically get this ability to take and divide up a hard drive into multiple virtual EOS devices, boot from them, and to do so very quickly. So I can say, boot up SmartFILER, AdamCalc, what? AdamCalc here, and I software AdamCalc. Now we have a copy of AdamCalc booting very quickly from the hard drive, as one example. Or we can do others as well. And instead, I'm going to hit wildcard. We'll boot into TDOS, which is basically another implementation of the CP/M-compatible operating system, but with support for the hard drives here. We can see right here the access much faster. Not only do we have access to being able to use software much faster here too, but we have access to high capacity volumes and to be able to use CP/M much more effectively. Compatible operating. There we go. Of course, there are all of the modern solutions, which I showed you FujiNet here, but ADE is also another. The ADE also superseded the earlier VDE. So all modern solutions that allow you to use SD cards as local storage. FujiNet adds the ability to do network storage and networked applications, and to do all this very quick, easy way. And he's actually Adam. Basically, when we start thinking about things in terms of storage, again, Adam thinks of medium in terms of 1024 byte blocks. These are 1K blocks. DDPs have 256 of them. Original Coleco devices have 160 blocks. You had Micro Innovations double-sided, double-density floppies that could store 320K of data, or 3.5 inches at 20K. And the latest ones actually did have support for up to 1.44 megabytes, or 40 blocks. A little bit about EOS. EOS is basically the file system that exists in ROM. Every single Atom has this thing burned into the ROM of their system, and it's always there. You hit the reset button, the system goes into EOS and does the initialization. So the operating system is there. The thing about EOS's file system is that it is sequential. That means that even though everything is block addressed, it is assumed that files are going to be laid end to end on their target medium. And if a file is expected to grow then, and it is not the last file on the tape, then it is expected to have that file have to be pre-allocated to its target size before the next file is written. And it's also assumed, as you can see right here, that the very last file on the tape is expected to have the capacity of the entire tape. So that this is used to advantage, for example, in the SmartFILER applications, so that the database can grow to fill the rest of the volumes. EOS file names can have 12 characters total. That is 11 characters for the file name itself, and 1 character for the type. That is always the last character in the file name, and it's always left justified with the file name. Everything pre-allocated. Due to a quirk of data type size, EOS version 5 uses a 32-bit block address. That means that EOS volumes can theoretically be up to 4.3 terabytes in size. Although that might be a bit difficult because, well, there are no subdirectories. Everything is flat. EOS 6, on the other hand, cuts that down from a 32-bit block address to a 16-bit block address, and thus EOS 6 volumes can be a maximum of 64 megabytes. Nice. And to kind of show what the unusual aspects of this and how this actually all translates out, I will take and load a copy of the my little Adam disk sonic screwdriver, which has a disk mapping. We'll take and here, okay, great. AdamCalc. Download a copy of AdamCalc because this has a file system that has files with whole. Oh, come on. Give it a second here to load up. Okay. other right here, and we'll have a little look on this file system here. And I'm going to go into drive funcs to get the map function. New map. And we're going to see something rather interesting. You'll see right here that we have the files as they're laid end to end on this tape. And you can see the very last block that's used on the tape has a yellow dot here. And you'll see that there are two greens here. A light green means that the file, that this is data that's currently used by the file, and a dark green indicates that this is unused stuff. This is unused space by the file. And you'll notice that because there are multiple files on here, AdamCalc actually took and pre-allocated a certain amount of space after each one so that the file could actually grow bigger, and you can see the gaps here in this display. To deal with this, basically there are utilities that are called crunchers that are available, that are part of programs like a file manager and the like, to take this extra space and to crunch it down so that the files are laid end to end, with the disadvantage that the pre-allocated space that was previously there for the files is removed. There we go. Of course, we saw CPM. CPM version 2.2 supports 160K disk by default, supports the 256K DDP. It does support a RAM disk as drive M, but only 64K without patching. You have to use the Adam BIOS patch to basically get access to more RAM disk and greater disk capacity. But it is actually possible. It includes transfer programs, a backup utility, a formatter, sysgen, a basic configuration program to set various small configuration options. And with programs like ABP, the Adam BIOS patcher, it can be patched for other disk capacity. Whereas TDOS, for example, as we saw earlier, is a CPM replacement. Instead of using the 32-character text mode, it uses the 40-column text mode with an 80-column virtual display. It supports more disk capacity, also supports the Microfox IDE hard disk support, supports directories, supports timestamps, supports the EVE 80-column expansion natively, and supports devices like the MIB serial parallel card so that they can attach modems, terminals, other printers, that sort of thing. Speaking of expansion, so the first major bit of expansion here that we talk about are the AdamNet ports. We saw the AdamNet ports in the overview earlier, and there are two of them, one in the front, one on the left side. And actually the printer connection is actually AdamNet as well. You'll see right here that the connector that's used for AdamNet is the standard 6-position, 6-contact connector, aka the RJ12, but it is cross-wired, meaning that the connector, that the pins are flipped on the other side of the cable. The way that AdamNet essentially is connected topologically is that peripherals are daisy-chained together, and they are done so using the two AdamNet connectors that are present on every AdamNet peripheral. There is a specific one for input, which means the cable going in, and there's a one for output, with the cable coming right back out. Of course, one of the more interesting aspects of this as well is that you have, because this whole topology is extremely passive, there are no active components in AdamNet. You can use basically T-adapters to take and increase the number of ports that you can daisy chain off of. A little bit about AdamNet's physical characteristics, the link level characteristics. AdamNet transmits at 62,500 bits per second, or 60.5 kilobaud. It uses a single wire for receive and transmit. And that single wire carries an inverted open collector bus. The bus is high if all connected devices are high, and the bus is low if any device drive is 0. And one of the interesting aspects of how AdamNet actually works, it uses a very unusual characteristic of the 68801 microcontroller in its transmit control register called wait. And if the wait register is asserted, then the serial device will literally ignore everything coming down the line until a break is received, or rather 10 zeros in a row. At which point the wait register gets tripped, gets reset, and the device in question starts listening for traffic again. And this is used to literally implement the multi-device network that's present on AdamNet. The other major strange aspect about AdamNet in and of itself is that it uses the 6801, specifically the master 6801 that's present on the Adam itself, which is different from the 6801 that drives the tape drives, to implement DMA into Z80 memory space using the memory input and output controller chip that's present in each and every Adam. This means that the Z80 can make a request for some piece of data, go off and do some other business, and the 6801 will go do the I/O operation, put the result into the Z80's memory space, and then set a byte in memory indicating that the device operation is complete, that the Z80 can check sometime later. And this is used by the disk drives, DDE, ADE, FujiNet, the printer, the keyboard, etc., etc. So this divides up into a few parts here. We have the master 6801. And the master 6801 implements the core aspects of AdamNet. With all the communications to the peripherals, all communications in AdamNet start from the Adam itself. And it's connected to the Z80 via the memory input-output chip. Again, it provides the DMA channel from 6801 to Z80 RAM, and it basically watches an area of Z80 memory called the process control block, where this bit of information holds the number of devices and their device control blocks. There's a device control block for each and every device that is found on AdamNet. Whenever the system is first reset, one of the first things that it does is it goes out and does a roll call and asks for every single device in succession. It literally just counts up all 15 possible devices and asks them to return a status. If a status is returned, a device control block is set aside in memory for it. This effectively means that there is a maximum of 15 possible devices that can be present on AdamNet. So if you read the DCB, you can get the status, and whenever a particular I/O operation is complete, that same status byte gets its upper bit set to indicate whether or not a command is actually complete. Again, reading and writing are completely asynchronous, but there is no queue. So basically what this means is Z80, again, asks the AdamNet to go do something. AdamNet goes and does it. Z80 basically asks, are you done yet? Are you done yet? Are you done yet? And by default, the PCB sits at the very end of memory at address FEC0, but it can be moved to anywhere in memory. And of course, not only do you have the master 6801, but you have all the peripheral 6801s as well. There's one ostensibly inside each and every peripheral. One inside the DDP, one inside the floppy drive, one inside the printer, and there's actually a 6801 all by itself just to control the two data drives that are present inside the Adam. And in each case, there is a 2K mask ROM inside each one that's split literally down the middle. The first K of the ROM contains what is known as the network interface module, which has all of the bits and pieces of routines to act as a device on AdamNet, sending and receiving packets, handling all of that. The other side is the application side, and that is different for each and every device. And that is the logic that basically, for disk drives, it's the logic for talking to the floppy controller, handling all the disk commands. For the printer, it's the logic to handle moving the daisy wheel, handling the carriage, doing that stuff, and so on and so on and so forth. For the DDP, it's all the logic needed to take and turn on and off the motors at the right times to take and move the tape transport from one place to another. And in each case, the NIM basically sits and listens and goes, okay, it looks at each packet, each packet that comes across, and looks at the first byte of each packet and realizes, okay, upper nibble contains the device ID. It's one of 15 possible devices. Is it for me? Okay, if it is, then you take and process the rest of the packet, you put it off to the application. Otherwise, we set the weight bit in the 6801 transmit control register. You wait until the line goes quiet, which is essentially a break, and NIM again starts to listen back. These are the different AdamNet packet types. And basically they're all divided up so that the ones without the 7th bit set right here indicate ones that go from the Adam to the peripheral, whereas ones with the high bit set are responses going back from peripheral back to the Adam. And I have an entire document specifically detailing what each of these packets has, the content of each of these packets, and how they're timed out, how they happen in succession, and all of that is in the reference section at the bottom of this. So whenever AdamNet first comes online, it does a reset, which is the first thing that it does is it's trying to take and synchronize both the 6801 and the Z80 clocks so that they can access the same chunk of memory through the memory input and output controller without bus contention. This is absolutely critical, and but it must be the very first thing done. Again, once this is done, we ask all the devices for status, and for any responses received, we set up a DP in memory. Finally, so that's pretty much AdamNet in a nutshell right there. But there are other expansions as well. You've got the write slot, and the write slot is exactly like the ColecoVision expansion slot. For example, you've got things like the expansion module number 1, which basically is a complete Atari VCS 2600 crammed into a box with the video output going out to a pin on the expansion slot, which gets sent to the ColecoVision here so that you can play external games. So that's that. But you also have interesting little tidbits like the auto dialer. And this was, if you bought a copy of the address book, you got you got this along with the address book. This plugged into the expansion slot, you plugged it into your phone, and it would take and dial the phone for you. The thing about this is that you can't use these today because this literally relies on the old AT&T pulse dialing technique that basically died in the late 1990s. So, but the particular peripheral did indeed exist. You also had other expansions as well. The nice thing about the write expansion is that it has all of the address lines, all of the data lines, all of the clock lines, and the bus arbitration lines available on this connector. So you can pretty much use it for anything. And you had devices like this 80-column display here that took and provided a nice high-quality 80-column display for C. And you also had basically, you saw the 3 internal slots. And I'll take and bring them up here just as reference on my overhead. We can see them. I will zoom in just a bit. Okay. And we can pull this guy out. Take a look. And we see the 3 internal expansion slots. They're labeled 1, 2, and 3. Internal slot number 1, you'll see the connector for this guy is much smaller than the others, and thus has very limited I/O capability. It's only meant for a couple of different things. In particular, it was originally meant for the AdamLink modem. It was meant for the AdamLink modem. Plugged in, the little hole up top was the adapter cable that went out to a standard modular phone jack connector. There was your modem. But it also could be used by devices like this dual serial interface, because the modem was, in essence, a serial interface with a modem attached to it. Why not just omit the modem? It turns out there were enough I/O pins here to support 2 serial ports. So you have a dual this is actually a Motorola license of a Signetics part 2681 UART to provide the two serial ports, one ostensibly for a modem and the other ostensibly for a terminal. We also have a crystal here for clock, some drivers, and some bus glue. So, I mean, pretty simple, straightforward. But you also can use slot 1 for the IDE hard drive adapters to attach a hard disk. So I have one of those. I didn't bring it in here with me, but I have one of those that goes into that first slot as well. So again, even though this particular slot has limited utility, you can still cram a lot of different in there. The second slot, which we can see, and pop up in the overhead. The second slot is a bit larger and has more address lines, has more of the bus signals available. It was originally intended for language cards. By language cards, I literally mean like these things right here. You can see that these are basically ROM replacements for the SmartWriter to take and replace the text, the English text, with French or German or the like. But these days, we typically use them for memory addresser cards so that we can basically have much larger RAM expansions in slot 3. You'll see that there's actually a connector, a little DuPont connector here that goes to the other card to provide the missing address signals in the third slot. Another common use for them here, you can see the header for it here is for a parallel port. So you have the ability to take and hook in another printer other than the printer that comes with your Adam. And this really could have been more use before FujiNet, because now FujiNet has a built-in, complete printer emulation. This is, less pressing of an issue. But you'll also see that there is an IC socket right here for an EEPROM, and the purpose of this is to take and provide, for example, a boot PROM. If you're going to use an IDE hard drive and you want to be able to boot that IDE hard drive up immediately without having to put in a boot DDP or boot disk, then you can take and attach a boot ROM here. There we go. Finally, you have internal slot number 3, which was really meant for RAM expansions. And the first RAM expansions that were available were the 64K RAM expansion. And if I actually take, I will take and turn off my system here, blow anything up. We can see right here, this is two 512K SRAM chips here, plus a GAL to act as bus glue here to implement a 1 megabyte RAM expander. We'll see here, the back of this card here is a pair of DuPont pins that connect up to the addresser card that's over here. Much the same way. So, simple, straightforward. Go. So, funny thing is, with the way that the expansion system is set up, the memory input and output controller can page in and out 64 kilobyte sections of memory split into 32 kilobyte upper and lower sections. And the bank select register that's used for this, hex port number 42, can use a number anywhere from 0 to 127, so 128 possible banks. If you multiply that out, that comes out to a maximum RAM expansion size of about 8 megabytes that you can cram into slot 3 with an addresser card in slot 2. If the addresser card isn't here, the RAM card can still be used, but it can only be used as a 64 kilobyte RAM expansion. That brings us to the final section of this video, and that is programming. How do we program this goofy thing? Well, you saw the native environments, at least a couple of them. You saw SmartLOGO and you saw SmartBASIC. Those are wonderful environments on their own. And if all you really want to do is just do like simple native code development, you can spend your whole life in those two environments and get a lot done. But if you want a bit more power, you can leverage the ability to do cross development and even some native development for both assembler and other high-level languages. But for this, what we're actually going to do, we're going to attack this mostly from a cross-development perspective. So, what's this all about? Well, hold on. I seem to be... Again, basic programming. How do we think of this particular system? Well, it's a Z80 running at 3.58 megahertz. And it's a Texas Instruments 9918A video display processor with 16 kilobytes of video RAM. You can treat it as a ColecoVision or as an Adam. An Adam, whenever an Adam program starts, it always boots the first block of a particular medium and puts it at address C800 hex. So pretty much, an Adam application can use OS 7, can use the OS 7 ROMs, it can use the SmartWriter ROMs, or it can use the EOS ROMs by switching in the appropriate memory input and output controller bank. And you can develop either natively using something like Mac Adam or writing in CPM, that sort of thing, or you can do cross-development using something like Z88DK or SD. Let's talk a little bit about how the MIOC takes and splits things up. The MIOC is the memory input and output controller chip, and its whole purpose in life is to basically provide not only the ability to segment off and provision memory so that we can talk between intrinsic and extrinsic RAM, that is internal RAM versus expansion RAM, versus RAM versus ROM versus the different ROMs, etc., but also provides the arbitration so that AdamNet devices can DMA directly into Z80 memory space. But for the purposes of this, we have a set of memory maps, of which there are 16 possible combinations, modes that we can use. By default, the system comes up in mode 0, which is SmartWriter on EOS and the lower chunk of memory with 32K of intrinsic memory in the upper 32K of RAM. So lower is 0 to 8,000 hex, upper is 8,000 hex to FFFF. Okay. The other major common mode that is used is what's called SuperGame mode. SuperGame mode is mode 3. It gives us access to the OS 7 ROM and 24K of intrinsic RAM and the lower 32K of memory, while giving us a full 32K of memory in the upper block. And all of the super games basically use this mode to leverage the features of OS 7 while leveraging the benefits of having all this extra RAM that we 50 some odd K actually muck around with. And there are others as well. For example, you literally can set up mode 1, which a lot of Z88DK programs, if you target Adam by default, which will basically say, okay, well, the lower 32K is our intrinsic RAM, and the upper 32K is also intrinsic RAM. With the twist that when EOS first starts up, it copies itself into the upper chunk of memory so that it can be used. So if you take and boot in and switch to mode 1, you get the added benefit of being able to use all the RAM. And if you need to use some of the RAM that's normally being used by EOS, well, that's fine. You can write over chunks of EOS. For example, if you don't need the file system functions, you can get rid of those. If you don't need the low-level blocking functions, you can write over more still and have access to more of a solid 64K chunk of RAM than you would normally otherwise. So again, lots of options. And the twist here is that hex port number 42 can select other expansion RAM banks, so that when you take and select a chunk of expansion RAM, or extension, or extrinsic RAM, you can select other banks up to 8 megabytes worth of. So it is extremely flexible, if a little bit on the coarse side, because you're always dealing in terms of 32K bank chunks. So other things too, again, I mentioned before, super game modes use mode 3 for 52K of usable memory for super games and access to the OS 7 routine. Very useful in their own right. And many Coleco applications often take and switch in the SmartWriter ROM for a moment so that it can use their routines for writing proportional text to the screen, writing 40 columns worth of text on 31 column display screen, etc., etc. All that nifty. With that, we can basically take and start to do something very simple in C. You can do hello world in C. And this is really all you have to do. You can follow these instructions here in this document. Build your copy of ZCC, set up your environment. Then you can clone a copy of EOS lib. You can build it, copy the headers and the library into your include libraries here. Turn around and do the same thing to provide smart keys lib so that you can draw smart keys like displays. Put those in, and you can basically do you can build OS 7 lib in the same way to have access to OS 7 functions from within C. You have access to all the major functions. And finally, this is really all you need to do in order to do hello world. Just set aside a little buffer here, put hello world in it, load up ASCII in the DDP, write it to VRAM, and then just kind of sit there. Sorry about that. If this seems a bit strange, I realized that I was paused when I was doing this particular section, so I'll do it again. Finally, we get to basically doing programming here. And programming section is pretty straightforward because you have the ability to do both native and cross development and to do it in a very effective manner. So for this, we're essentially going to be using the excellent Z88DK cross compiler suite here, which can generate runnable artifacts entirely from C or assembler code and do so very efficiently. Do Z88DK, it's pretty straightforward. All we really have to do is clone our bits and here. All of these instructions, pretty much exactly, are in the document, run the build, do the set environment, and you wind up with Z88DK ready to run. Then you can turn right around and build the EOS lib to take and have access to the EOS functions that are in ROM. Build that using make. Take the EOSH, put that in include. Take the EOS lib, put that in CLibs. Ready to go. You can turn around and do the same thing with Smart Keys lib, a re-implementation of all the Smart Keys routines. SmartWriter ROM. I implemented those literally from scratch in C, so you can do Smart Keys type application in C. Pull that in, made exactly the same way. Copy the lib, copy the .h, ready to go. And the same thing for OS 7 lib, which gives you access to all of the bits and pieces of OS 7 for writing ColecoVision or SuperGames. Ready to go from C. Installed exactly the same way. Make it, copy the .h, copy the lib, go. Finally, this is everything you need to do Hello World in C. Or my little shout out to Isagi Electric, David Lovett here, who did this as HELLORLD. So all this really is here. It's very simple. We just include our EOS.h so that we have access to a couple of the VRAM functions. We set aside a 768 byte area for the screen here and just put HELLORLD in it. Then we take and load ASCII into the VDP. That loads it into the pattern buffer, write it into write VRAM, and then we just sit and spin. That's really it. And all you have to do to build it is run ZCC in this manner. You just specify the Coleco main type plus Coleco, subtype equals Adam. Then you use create app, and this is a very special chunk of code right here. This uses appmake to take and package your application into a digital data pack form that can be loaded by an emulator, or if you have a FujiNet, loaded, or an ADE, loaded onto a real Adam. Finally, we have the source file name, hello.c, and we link against the EOS library so we can have its function. So what you see at the end of all of that looks like this. And A, B, Go. And there you go. Hello world, right there, ready to go. Yay. But wait, we can turn around and do this even faster. We can do this in Assembler as well. And this is everything that you need to do this in Assembler, along with a handful of all of the EOS routines here and their jump table location. All of this is documented in the technical information that I have at the end of this document. I have table numbers, so that I have access to the name table, the pattern table, the color table. These are used by the write VRAM routines so that we can take and so it can point into the correct tables. And we have default addresses. Of course, we have one block worth of data to load. Very small program. This is really it right here. We set up some BDP registers calling write reg in each case to write these things to the very safe. Then we take and turn around and immediately clear out all the VRAM. Zero it out because we don't know what state it's in. We then turn right around and call a init table on a number of different tables to set up the pattern, the name tables, and the color table. And then we go ahead to the addresses for them. And then we go ahead and set blue on white for all patterns. Alt color table, okay, great. 32 color entries. We want white on dark blue, so F4. And we call fill VRAM to quickly do that. Then we go ahead and call load ASCII, just like the program. And we set up some parameters, point to our text here, set up our name table, and then call write VRAM. And then when it's all said and done, we sit and end. The only other thing that we have to do here, because we're doing this in Assembler, we also have to handle the bootstrap itself. Bootstrap is simple enough. Recall earlier that block 0 is always loaded into C800, so we have to take and do that here. I make a special section called bootstrap here so that the compiler will treat this separately, but AppMake will know to use this. We take and do a little house cleaning to put the current device into the location called current dev. Then we go ahead and set the current memory map that we want to use. Recall earlier that in the MIOC table that option 1 is 64K of intrinsic RAM everywhere. Go ahead and set that. We take and write that out to the MIOC control port, 7F. Then we set up a little house cleaning here to say we want to load our one block and do a load loop. Basically just does a little house cleaning here, reads in the block, puts it in its proper place, does any arithmetic to read in the next block. Finally, when it's all said and done, we just jump to the start of our program. And that's really it. Boom. Building this is actually very nice too, because all we really have to do, we have to build the binary with Z88DK, Z88M, then we package it with Z88DK AppMake. We have to do that ourselves because we're doing it in Assembler now. But still simple enough. -B means absolute binary here. We wind up with a bin file. And then we use that -B as an input binary here, the org, so that we start our absolute 0 and set up the appropriate AppMake plus Adam so that what comes out is a DDP in the right format. You run those two things together, you wind up with a product, and this is what it looks like. And we can see it right there. Bam. So we've written hello world in C, we've written hello world in Assembler. Right there, ready to go. Very easy to get started. And there's plenty of technical information at the end of this document that you can use to your advantage to take and write software. plenty of good ways to get. That brings us to the very end of this presentation, / reference / compendium, everything. There are a ton of references here. I want to thank, very much so, I want to thank Rich Duraco, William Hicks Jr., Joe Blinkel, dear God, so many people, Henry Reutveld, and so on and so on and so on, for helping me all this. Peter Puskarich for watching the John Lundy. You have wonderful vendors like John Lundy who are providing new peripherals. The Brewing Academy, also the Adam News Network providing IDE adapters. You have vendors like 8-Bit Millie Games who are making new games for both the ColecoVision and the Coleco Adam. 8-Bit Millie also provides the wonderful Adam archive, which we have as the very first link to this reference section, which provides every bit of software that you could possibly imagine to want, to need for your Coleco Adam and or ColecoVision. All right here, ready to go. In fact, I'll just go through a couple of these here. I mean, you have Lundy Electronics, so you can have access to brand new Coleco Adam peripherals. I mean, you have the Adam News Network, so you have all sorts of things like Adam Printer print wheels, print ribbons, data packs, whatnot. There is eColeco, which has all sorts of odds and ends for ColecoVision. The Brewing Academy is a recent vendor that came over from the Atari 8-bit side of things, and he's starting to provide a whole bunch of Coleco Adam peripherals, just bits and pieces here, including a complete ColecoVision NUC, and we're hoping eventually an Adam version of it once we get a few things out. Just so much stuff. You can have a piece of BBS software called Adam BBS to run on your Coleco Adam as well. You can get it from here, either the free or the commercial version. FujiNet.online, of course, for your FujiNet needs. Not only the Coleco Adam, but a variety of other platforms, and so on. There are a huge number of technical manuals as well, such as the Coleco Adam Technical Reference, good overview. The EOS Programming Manual, showing you all the EOS calls. You saw me go into detail on AdamNet, and this goes into even further detail, showing you not only the packet types, but also example packets, transactions, and their respective timings. You also really, if you're going to be doing programming, you also really want a copy of the 9918 data book, which basically details in detail virtually everything about the TMS 9918 chip. Not only that, but there are canonical ROM listings, so that we were very fortunate in that we have listings for the ROMs that are currently in each and every Coleco Adam with comments. So you can really dig down in and see what they're doing down underneath. Not to mention, you also have the programming links that above for a copy of ZDDK, OS7lib, EOSlib, SmartKeys, as well as links for adapting existing audio tapes, as well as a complete demonstration video showing how you can take and adapt existing audio tapes as well. With that, I'm going to go ahead and leave this talk here as it is. I want to thank each and every person that has helped me put this together over a period of no less than a month. This may be the final version of the talk. If not, then I will take and do another run here. But it's been fun, guys, and I hope that everybody finds this useful. And I'm hoping that people will not only see this video here, but other videos in the Retro Computing Archaeology series as canonical bricks in a much larger picture to try and fill in gaps of knowledge in the retro computing and retro gaming community. That, I want to thank you all very much.